All right, so the agenda for today's session is we're going to be covering statistical inference, starting with a notebook from our previous session, which I will use to reiterate some of the important concepts that you have studied. So I hope everyone remembers Mendel's model of P flowers. Even if not, I have it open right here with me. So, just to quickly catch you up on this, Gregor Mendel was an Austrian monk who is widely recognized as the founder of the modern field of genetics. Now, he experimented with pea flowers, where either these plants could have purple flowers or they could have white flowers. Mendel's model of pea flowers proposed that there is a 75% or a 3 by 4th chance of having purple flowers and a 1 by 4th or 25% chance of having white flowers. For this, he conducted a study. We're going to try and simulate that study and look at the observed test statistic and then see if we can reject or if we can or if we will fail to reject the null hypothesis. So anyway, this is the test statistic that you're going to be using, and whenever you want to test a hypothesis, you always follow these series of steps. So you have to be familiar with these. All right, so in this case, the test statistic is the modulus of the proportion of purple flowering plants minus 0.75. So let's see where the magical 0.75 figure comes from. Essentially, what we're going to be doing is suppose he grew 100 plants and then he observed that 60 out of 100 of them uh, ended up having purple flowers as opposed to white flowers. So then the percentage of purple flowers would have been 60%. However, Mendel's model proposed that the percentage should be 75%. So in this case, we construct two hypotheses. You construct the null hypothesis, which represents no effect, or you represent the alternative hypothesis. So under the null hypothesis, we would say that this model is correct, in which case we can simulate data under this null hypothesis. And then you choose a test statistic. So the test statistic has to be chosen in such a way that it favors the null hypothesis when the value is small, and it does not favor the null hypothesis, or it favors the alternative hypothesis when the value is large. Generally, that is the rule of the hand. So if I take the difference of the proportion of purple flowering plants from 75%, which is the proportion that I would have expected based on Mendel's model, then in that case, this test statistic would have a higher value. The difference would be higher the further that I deviate from this model, and it would be lower. And if it would be lower, it means that I can support this model. So anyway, before looking at this, what we're going to do is we're going to take this statistic and we're going to simulate the null hypothesis, which we can very easily do programmatically. So we don't need to get into the complexities of the code, but rather let's get a high level view of what is happening. So this is what we have. This is an array, a NumPy array where you have purple repeated thrice and then white repeated once. We are going to use this array to randomly pick one particular color or one particular value. Now, if you were to pick something from at random from this array, then the chances of picking purple would be 75%, and the chances of picking white would be exactly 25%. So I use this to generate data. We can leave this function for now, and I'm going to just show you the data generating process. So we repeat the process 10,000 times to generate data. All right, so for those number of repetitions, you generate uh, basically, you pick something at random from the array A, which means that there's a 75% chance of picking purple, and you pick a total plants number of times. So now let's see what total plants is. That is 929. And we have this particular number over here because in the study that Mendel conducted, he worked with exactly this many plants. So we are going to eventually going to be simulating for this particular value. And from these 929 plants, basically he observed how many ended up being purple flowering and how many ended up being white flowering plants. Keeping that in mind, the observed test statistic, because right now we're just simulating under the null hypothesis that is given to us. In actual, when Mendel would have conducted this experiment, he would have observed a certain statistic as well, which would have been computed in the similar way to, well, it would have been computed according to the formula that we just saw. So, for instance, if 700 out of these 929 plants would have been purple flowering, then our observed test statistic would have been 700 divided by 929, and whatever proportion that gives you, you would subtract 0.75 from it and then find the modulus of that. This is the observed statistic. The observed statistic is that for your actual final experiment. So this value is already given to us. And now we want to check if this value tells us that there is actually an effect or if the effect is not statistically significant. With that being said, now let's look at our test start function. This function simply calculates the test statistic for you. So when I repeat the experiment 10,000 times, then for each of the 10,000 times, I generate 929 random values based on this array. Then I compute the test statistic based on this function, which is simply I count the number of zeros then divided by the length of the sample, which should be 929. Anyway, with that, this is how we have called it in our function. You generate a new sample, you do it 10,000 times. For each new sample, you find the test statistic, then you append it to your list of test statistics. So let's observe what this gives us as well. So of course it's going to give you a NumPy array. I'm going to convert this into a data frame or a series for that matter. Okay, we have converted it into a data frame. It's just one column though. And then we're going to try and plot this distribution. That would be your null distribution. So this is what my null distribution looks like for 10,000 values. I can modify this number and see how the effect changes as well for your information. All right, anyway, so the line that is marked in red, that particular line represents the observed value. This is what Mendel actually observed in his case. And we want to see if based on our null distribution and the observed statistic, is the observed statistic giving us a value that is significant enough to accept the null hypothesis? Which means to accept that his model works, or are we going to reject this model? This is what we're trying to observe. And a couple of things come in at this point. The first concept is that of your significance level. The second concept is of your critical value, which maps directly onto your significance value. And the third concept is that of p value. We're going to start with the p value actually, and we're going to try and compute the p value. So let me just, okay, I don't have it open right here, but I do have it written down over here. So we're going to go back to the definition of the p value. So the p-value is the chance under the null hypothesis. When you say under the null hypothesis, it means assuming that the null hypothesis is true. In this case, it means assuming that Mendel's model works. All right, so the p-value is the chance means it's the probability under the null hypothesis that the test statistic is equal to or greater than the value that was observed in the data. So it means in actual it's telling us okay, what are the chances that if the null hypothesis were true, if we knew कि Mendel का जो model है it worked, तो फिर what were the chances of observing the value that you observed or observing a value higher than that. Essentially that just means the area of the graph to this side, to the right side of your observed statistics. observed statistic. Anyway, so if your p-value comes out to be 0.05, for instance, so roughly translates to there was a 5% chance कि आप ये particular value या इससे कोई बड़ी value observe करते, given that the model actually worked, or given that the null hypothesis were true. And 5% chance is not a very big chance. On the other hand, if your p-value obtained was, for instance, 50%, it means that there is a big chance that you would have observed this value if the null hypothesis were true. And very simply, that tells us it probably means the null hypothesis should be true. अगर p वैल्यू आप बहुत छोटी ऑब्जर्व करेंगे तो दैट मीन्स दैट द नल हाइपोथेसिस probably isn't true. It means that if there's only a 5% chance of observing this value or a value bigger than that, given that the null hypothesis is true, so that means कि जो आपने value observe की है, it is probably just because of chance. It does not mean that the null hypothesis is actually true. So essentially, the next question that comes to mind is, okay, then what exactly is how do you define a cutoff for the p-value? Like, कितनी p-value आनी चाहिए जिसकी basis पे आप कह सकें कि we can accept the null hypothesis? और अगर like उससे आपकी कम p value होगी तो then you can say that okay, we cannot accept the null hypothesis. So essentially you don't accept the alternate hypothesis, either you accept the null hypothesis or you fail to accept the null hypothesis. It means you don't have sufficient evidence for it. Before we define that particular threshold, let's try and calculate the p value for this particular case. And इसको compute करना shouldn't be very hard. We know that we made 10,000 repetitions, right? And her repetition के against we would have gotten one particular statistic की value. एक टेस्ट स्टेटिस्टिक आया होगा हमारे पास against each of the 10,000 times that we repeated this experiment for. So I just have to calculate the number of times that this statistic was greater than the observed statistic, greater than or equal to, because that is literally exactly the definition of my p-value. In this case, when I run this, so it gives me a value of 54.8%, and that's pretty high. That essentially means that also if this red line was more towards the right, then the value would have been smaller, because essentially calculate ये area ही कर रहा होता है towards the right under the null hypothesis. Anyway, now the threshold that you put on your p-value is what you can call alpha, or alpha means the significance level. So if I set my significance level to 10%, for instance, that means कि अगर मेरी p-value जो है, if it's going to be less than 10%, then I will not be able to accept the null hypothesis, because then I'm saying कि if like it's less than 10%, then you probably obtained your observed statistic just because of chance. If it's more than or equal to 10%, then I'm going to accept it. In this case, suppose if our significance level was 10 or 15 or even 5%, you would accept the null hypothesis. अगर आपकी p value उससे कम आती, then you would have failed to accept it. And with that, I'm quickly going to show you that for one particular example, here we are given that suppose the observed test statistic was 3.2. अभी जो हमने example में देखी है, that was not actually 3.2, that was 0.08. So you can modify this value, play around with it, and see how that changes your conclusions as well. So for now, if the observed test statistic was 3.2, then the p-value obtained was 0.0243, which means just 2.4%. So अगर आपका significance level 5% या 10% पे set होता, तो you would reject the null hypothesis. Are there any questions up until this point? All right, since there are no questions, we're going to be moving on. Again, I will just quickly reiterate one important thing over here कि जब आपका 5% था सिग्निफिकेंस लेवल तो आपने रिजेक्ट किया था नल हाइपोथेसिस को फॉर योर गिवन p वैल्यू ऑफ 2.4%. Over here, in this case, you fail to reject the null hypothesis. In neither of the two scenarios do you say that you are going to accept the alternative hypothesis. With that, let's look at our practice question. I know that a lot of these concepts can be very daunting at first, which is why it's important to revisit them later as well. And we're going to look at this through another example too. But these are very important concepts though. So now let's look at a study. You're given that a study evaluates the effects of a new sleep enhancing therapy to improve sleep quality in adults. All right. So एक आपका null hypothesis होगा इस study में और एक alternate hypothesis होगा, alternative hypothesis होगा. I've written both of them down already. So the null hypothesis is represented by age 0 generally and the alternative hypothesis is represented by age 1. So H0 is that the new sleep therapy has no effect on sleep quality. And जो null hypothesis होता है, it always assumes that there is no effect. All right, this means that the mean sleep quality index of adults. So essentially, what you are measuring is the sleep quality index. And you are told कि जो sleep quality index है adults का that are receiving the therapy must be the same as that of the general population. You are given a value of 50 in this case. So you are given that the sleep quality index for the general population is 50. And under the null hypothesis, you say कि जिन लोगों को आप ये sleep therapy दे रहे हैं उनका भी 50 ही होगा because this therapy has no effect on them. Alternatively, there is one other way of saying the same thing. In this case, हमने टेस्ट स्टेटिस्टिक को डायरेक्टली एज्यूम कर लिया हमने डायरेक्टली ये ले लिया कि हमारा टेस्ट स्टेटिस्टिक जो है इट विल बी एग्जैक्टली द वैल्यू ऑफ द स्लीप क्वालिटी इंडेक्स because your alternative hypothesis is of course going to be that there is some effect. So your alternative hypothesis is that this sleep therapy does have an impact on the sleep quality. It essentially improves sleep quality. And under the alternative hypothesis, you can say that the mean sleep quality index of people who are receiving this therapy must be higher than that of the general population. This is why my test statistic of sleep quality index works because in order to pick a good test statistic, you just want कि if the alternative hypothesis is going to be supported, तो टेस्ट स्टेटिस्टिक की वैल्यू हाई होनी चाहिए. If the null hypothesis is being supported, then the value should essentially be low. Alternatively, another test statistic that I could have taken for this study would have been the difference in mean sleep quality indexes of the general population and the people in this therapy. In which case, under the null hypothesis, the difference should be zero, which means no effect. दोनों के mean same होंगे and in under the alternative hypothesis the mean should be greater than zero. Are there any questions up until this point? I hope everything is clear. All right, on that note, moving on. So let's look at the graph that we have been able to generate. Using this graph, now I am going to quickly reiterate the concept of critical value as well. So आप एक certain significance level pick करते हैं. For instance, the significance level that I picked was 15%. So 15% से जो आपकी value correspond कर रही है, by the way, in that case, if I'm picking a significance level of 15%, so this green line represents your critical value. If my significance level was 15%, it means कि ये जो blue वाला curve है, which is the curve of the null hypothesis, इस curve में जो area है to the right of your green line, that would have been 15%. So that is how you can how you can interpret the concept of significance level. And the value that is here on the x-axis is the critical value. That is why we say that the critical value just corresponds to the significance level. Are there any questions? All right, with that, moving on. Okay, all right. So let's see. I have given some values to you in a table over here. So I have given you essentially हमने probabilities के साथ work करना है, and I can't expect you to calculate these probabilities just by looking at these curves. So I have given you some values already. Such as, for instance, now we know that our critical value is 58. It's 58.22. I've just written it down as 58. So the probability that x is greater than 58 under the null hypothesis curve as well as under the alternative hypothesis curve. Essentially ये सिर्फ area ही होता है. So ये जो green में area highlighted है, that area is basically 0.05. Then I have it for less than 58 as well, and then I have it for greater than 60 as well. Now let's look at the first part, which we've already discussed this, but to like quickly go over this as well. What is the significance level, or what is alpha? My bad. Anyway, I will fix that later. So what is the significance level? In this case, I can see significance level जो है, it must correspond to my critical value, and my critical value is 58.22. And obviously, my significance level must be the area to the right of my critical value under the null hypothesis. So this is what I'm looking for. Under the null hypothesis curve, which is the blue curve, the probability that x, my test statistic, is greater than 58, which is 0.05. That means that my significance level was exactly 5%. And essentially, ye wali she is 95% hai, because obviously to the opposite side of this, my area must be 1 minus whatever I've obtained for this one. Are there any questions at this point? So I'm going to write this down. You are working with a significance level of 5%. Next, you want to be able to calculate the p-value if the observed test statistic is 60, which is why I have given you the values for 60 as well. बेशक इसके ऊपर 60 plot नहीं हुआ हुआ. So you have to calculate the p-value if the observed test statistic is 60. I will keep this open and I will pause over here for 30 to 40 seconds to give you guys the time to try and work this out on your own. Then if someone wants to volunteer a solution, that's wonderful. Even if you don't want to do that, at least pause and try this out on your own. All right, I think that that should be enough. Can someone tell me the answer to this? All right, so essentially, if I would have made another mark at the point 60 here under my blue curve, my null hypothesis curve, So then the area to the right of that line under the blue curve would have been my p-value, because that would have been the probability of observing a value of 60 or more under the null hypothesis. So that is actually 0.03, which means that I have a p-value of, I'm just gonna write this over here. This means that I have a p-value of 3% or 0.03. Are there any questions at this point? So the next question is, are you going to accept the null oh, my bad. Are you going to reject the null hypothesis or not based on these two values? So again, I will give you guys a few seconds to process that on your own. Are you going to reject the null hypothesis or not? Okay, can someone answer this question for me? Okay, essentially, when your p-value is less than your significance level, you reject the null hypothesis. Since your p-value of 0.03 is less than your significance level of 0.05. So when this happens, then you reject the null hypothesis. On the other hand, if my observed statistic was suppose 55, so I can even just look at the graph and I know that it is towards the left of my green line, which means that the p-value must obviously be more than 0.05, in which case I would fail to reject the null hypothesis. Are there any questions before we move to the last part? Okay, so lastly,
Can I have a question?
yes.
Can you repeat the line where you said K, where we failed to reject the null hypothesis? What did you say?
Yeah, absolutely, sure. So essentially आप सबसे पहले ये चेक करते हैं कि आपने significance level क्या सेट किया है. Then you look at the observed statistic को use करके आप p value calculate करते हैं. अगर आपकी p value जो है, if it is less than the significance level, then you reject the null hypothesis. If it is greater than the significance value, then you fail to reject the null hypothesis. I'm just gonna move this to OneNote real quick and show you guys this a little more clearly as well, because I feel like शायद यहाँ पे there is a little confusion. I'm just resharing my screen. I am opening OneNote. Is my screen visible again?
Yes.
Okay, thank you. So let's see. Essentially, अभी आप red वाले curve को बिल्कुल ignore कर दें, which means कि we are only concerned with these values as well right now. So यहाँ पे मैंने अपना significance level mark किया हुआ है. This is my critical value. And ये मेरा significance level है, which is 5%. 5% इसीलिए है because इस critical value के इस side पे 5% का region है. और सिग्निफिकेंस लेवल सेट करने से एग्जैक्टली होता क्या है? इट मीन्स कि अगर इस एरिया में आपकी वैल्यू आएगी तो आप नल हाइपोथेसिस को रिजेक्ट कर देंगे. अगर इस एरिया में आएगी तो इट मीन्स कि इट लाइक फॉलोज द नल हाइपोथेसिस, देन यू कांट रिजेक्ट इट. लेकिन अगर इससे आगे वाली वैल्यू में आएगी, इफ इट विल बी इन दिस रीजन, ये टेल वाला रीजन है, इसके लिए आप वैल्यू खुद सेट करते हैं. जितना बड़ा सिग्निफिकेंस लेवल सेट करेंगे उतना लूज हो जाएगा बाउंड. अगर मैंने 10% का सिग्निफिकेंस लेवल सेट किया होता तो दैट वुड हैव लुक्ड लाइक दिस. सॉरी आई मीन उतना टाइट हो जाएगा बाउंड, दैट्स एब्सोल्युटली माय बैड। सो ये मैंने 5% का सेट किया हुआ है, विच मीन्स कि इस रेंज में अगर वैल्यू आएगी 5% वाले टेल रीजन में, तो आई विल रिजेक्ट द नल हाइपोथेसिस कि माय ऑब्जर्व स्टेटिस्टिक जो मैंने वैल्यू ऑब्जर्व किया वो नल हाइपोथेसिस को फॉलो नहीं कर रही। In this case, आपने observed statistics 60 लिया, and well, I can very clearly see कि 60 तो यहाँ पे है, which is towards the right of my significance level, which already tells me कि इसका मतलब है 60 को accept नहीं करना. But for our information, हम p value calculate करके देखते हैं. And p value जो है, it is basically, it tells you the probability of obtaining a value of 60 or more given that the null hypothesis is true. So suppose अभी ये जो blue area है, ये area वही आपको बता रहा है if like the null hypothesis were true. That's what you assume if you're looking at the blue curve. So अगर मैं 60 से ज़्यादा वाला ये वाला एरिया कैलकुलेट कर लूँ तो दैट वुड बी माई पी वैल्यू बेसिकली, और वो मैंने यहाँ पे मेंशन की भी है, दैट इज 0.03। सो इसेंशियली अगर आपकी पी वैल्यू जो है इफ इट इज less than the significance level which is alpha, then that means that you will reject the null hypothesis. I hope that answers your question. Is there anything else though?
Yes, I get it now. Thank you.
You're welcome. All right, let's circle back then. अच्छा, अभी हम alternative hypothesis के curve को बिल्कुल भी नहीं देख रहे. We are gonna circle back to it though. So let's see what the next part is. Now you want to estimate the power of the study. So I have this open right over here because I want to quickly reiterate okay, what exactly this power means. Can someone tell me what a type 1 error is and what a type 2 error is first actually? Come on people, this much you should know. If I assume that my null hypothesis is in fact true, तो इसका मतलब है कि ये blue curve के नीचे वाला सारा area represents that the null hypothesis is true, basically. It means I'm only gonna look at this purple region. इस पर्पल रीजन के अंदर अगर वैल्यू ऑब्टेन होती है तो इट मीन्स दैट द नल हाइपोथेसिस इज ट्रू, बट इन एक्चुअल आई एम सेटिंग अ क्रिटिकल वैल्यू, और मैं कह रही हूँ उस क्रिटिकल वैल्यू से बाहर अगर टेल वाले रीजन में आंसर आता है तो नल को आपने रिजेक्ट कर देना है. सो इसेंशियली टाइप 1 एरर में ये होता है कि you obtain an answer here in the tail, and that means you reject the null hypothesis. But in actual, the null hypothesis was true. So type 1 error means rejecting the null hypothesis even when it is true. And type 2 error means failing to reject the null hypothesis when it's actually false. Are there any questions about this? Is this all clear to everyone? ऑलराइट, सो टाइप 1 एरर को तो हमने इसी के थ्रू अंडरस्टैंड कर लिया. अब जो टाइप 2 एरर है उसमें वी आर कंसर्न्ड विद द अल्टरनेटिव हाइपोथेसिस वाला कर्व एज वेल. एंड टाइप 2 एरर इज अगेन आई एम गोना रीआइटरेट इट. नाउ वी आर गोइंग टू एज्यूम कि नल हाइपोथेसिस को रिजेक्ट नहीं करना आपने. सो it is the probability, it tells you that you are going to reject the null hypothesis when, sorry, you are going to be in favor of the null hypothesis when in actual you should have been in favor of the alternative. So the statistical power is essentially the power to avoid this type 2 error. It is the probability that if the true effect is of a given size, if the true effect is of a given size means कि आपने null hypothesis को reject करना है. All right, so it means that if the true effect is of a given size, if you have to reject the null hypothesis, तो क्या probability है कि आप उसको successfully reject कर देंगे when you are supposed to reject it? All right, because if you would have accepted it accidentally, then that would have been a type 2 error. So essentially, we want कि हमारी power high हो. If the power is like 80, then what does that mean? It means that there is an 80% chance. It means your test has an 80% chance of correctly rejecting the null hypothesis. ऑल राइट, 80% चांस है कि वो इनकरेक्टली नल हाइपोथेसिस को एक्सेप्ट नहीं कर लेगा जब उसने रिजेक्ट करना है. With that, moving forward, so let's see how you actually calculate power now. So I'm going to look at one particular curve. Yeah, essentially इस curve में जो आपका highlighted area है, you can ignore everything else right now. We've already been through these factors. So the area that has been highlighted with lines is the area that represents power. Now let's try and understand why it represents power. Essentially, now we are saying, इससे पहले तक we were assuming that the null hypothesis is true. Whenever I would say कि under the null hypothesis, it means कि you are assuming कि अभी null hypothesis को आपने reject नहीं करना. Now the power is always calculated under the alternative hypothesis curve. All right, and look at the significance level that has been set. So ये जो line exactly marked है, ये critical value पे marked है, जिस line के right वाला area हमने shade किया हुआ है. So this particular line represents the critical value. अगर इस line के left side पे यहाँ पे tail वाले region के अंदर I would have obtained the area. I'm actually gonna quickly add a screenshot of this to OneNote because then that's just simpler. All right, let's work off of this. So this is my critical value. I'm just gonna mark this over here. All right, so if my answer would have been in this region, for instance, and I would have, you can say, if it was in this region and I wouldn't have, I would have rejected the, I would have failed to reject the null hypothesis, my bad. Essentially, I want कि अभी if I'm assuming that the alternate hypothesis is true, so I have to fail to reject the null hypothesis. If it was in this area, that wouldn't happen. I would reject the null hypothesis. So this would be my type 2 error. If I subtract that probability from this one and calculate this region, so this is where if I'm observing a true effect, I am successfully rejecting the null hypothesis. With that, let me see how we can do that in this particular curve as well. So यहाँ पे भी आपने alternative hypothesis वाला curve देखना है, which is represented in red. Now you can ignore what the null hypothesis curve is showing you. And we know that for the alternative hypothesis curve, the statistical power is always the area to the right of the critical value. So this is the area that you want to calculate if you want to determine the power. With that, I'm going to pause over here for a few seconds and give you guys the time to think about what the power of our test is. All right, can someone answer this for me now? Do we have an estimate for our power? 15%. Excellent. That's exactly the answer that we were looking for. So Bilal, you got it right. Because essentially ये value मैंने आपको यहाँ पे दी हुई है. The probability that x is greater than 58 under the null hypothesis is 0.15. Are there any questions at this point? All right, so I'm gonna write this down over here. 15%. And with that, we are going to be moving on. So I have one last question on bootstrap sampling. Can someone recall what bootstrap sampling is? Does anyone here remember bootstrap sampling? So आप एक ही sample में से resample कर रहे हैं essentially. Why do we need to do that? For instance, I have 10,000 samples in my study, and I want to increase the number of samples to draw a particular distribution. So one way of doing that is कि मैं और surveys conduct करूँ या और experiments conduct करूँ, however it is that I have obtained my data. I can just do more of that. But suppose in some cases, maybe the process is expensive, maybe it is just infeasible for whatsoever reason. So if I take my 10,000 values and I consistently resample from those 10,000 values, अब you would say कि अगर आप resample करेंगे तो exactly वही चीज आप बार बार obtain करते जाएंगे. That is not true. The reason for that being that you resample with replacement. So you can, if you put a if you put a value back into the bin, you have the same probability of taking it out and adding it to your subsample again, if that makes sense. So that is what you do in bootstrap sampling. The law that we follow over here is the law of large numbers. So you say कि essentially if your sample size is big enough, then your subsamples are going that are drawn from that sample should essentially it will resemble the original population anyway. So you have the treatment group and you have the control group over here, and let's see what this is for. Yes, this problem has been adapted to fit on paper, meaning that the sample sizes and numbers are much smaller than they should be in practice. Essentially, for bootstrap sampling, one of the requirements you can say is कि your samples should be big enough to begin with. क्योंकि अगर आपका original sample छोटा सा होगा तो उसमें से आप जितने मर्जी sub samples construct कर लें, you're not really gaining any useful information out of it. So you are investigating whether background music negatively affects exam performance. To assess this, you conducted an observational study by analyzing the exam scores of two groups of five students each with similar characteristics. All right, everything else is similar. We have two groups. Her group में we have five students. One of these groups studied with background music. This is your treatment group. The other group studied without background music. This is your control group. Each exam is scored out of 100 and ये हमने exam scores note कर लिए हैं. Now you want to, okay, to validate your hypothesis, you constructed a bootstrap analysis. The bootstrap samples and summary statistics are provided in the table below. My document just froze. So, for as long as it doesn't work, I know that initially you are required to state the null hypothesis and the alternate hypothesis. So, can someone do that for me? Or rather, at least take a few seconds and think about it. What would be the null hypothesis and what would be the alternative hypothesis? Can someone state the null hypothesis? Alright, so guys, the null hypothesis will represent no effect. In simple words, the null hypothesis is that that the background music has no impact on exam performance. And the alternative hypothesis is that that background music does have a negative effect on exam performance. Anyway, with that, let's move on. So that was your first part. I'm not writing these down right now. We can do that later. What are the sample means of the original control and treatment groups? So that just means कि आपने first group का mean compute करना है and आपने second group का mean compute करना है. These are your two original groups. Yes, was there a question? Okay, all right. Anyway, I thought so. I don't have my calculator on me right now, so I will add these answers for you later. For now, I want to move on to the next part. Which of the two test statistics? Oh yeah, I quickly want to show you how this works as well. So ये आपके पास treatment group वाला table है and ये control group वाला table है. And you have collected three subsamples from each group. All right, so I just want you to look at the initial values of the treatment group: 12, 35, 34, 51, and 64. And now look at each of these three subsamples. So see, इसमें 34, 35, and 12 is repeated twice, and you have 51. That was in the first one. In the second one, 35 is repeated twice and 12 is repeated twice. In the third one, well, 51 is repeated twice. So that essentially is how you are constructing subsamples from the original treatment sample. And then we have computed row means for each of them, but that's not important to us right now. And exactly वही same चीज की है हमने with the control group as well, where your values are 43, 65, 74, 55, and 80. So I have just sampled with replacement from that group as well. Anyway, which of the two test statistics, T statistic and Z statistic, is more appropriate for testing your null hypothesis? Justify your answer. Alright, so T stat hai hamare paas and we have Z stat. Here I want to reiterate what you have covered in class and how that applies. So I will pause over here for a few seconds again and give you guys the chance to go through this table of parametric tests, because non-parametric tests are not tested. All right, would someone like to tell me which test we're going to use in this case now? T test or Z test? So essentially, guys, we're going to be using the T test. The simple reason for that being, yes, Bilal, you are right. So the reason is that the sample size is less than 30. The sample size is small. And these are just two, three very important things to remember. All right. Next, let's look at part D. Oh, I'm just going to quickly add this over here as well. T-test since sample size is less than 30. A colleague suggests that the variance of the sample means for both groups appears too high. She proposes increasing the size of each bootstrap sample to address this issue. Do you agree with her approach? Provide reasoning for your answers. I'm going to pause for a few seconds again and give you guys the chance to think about this. All right, is this a good solution or is it not? So this is not a valid solution to begin with. That's a trick question, because essentially in bootstrap sampling, one of the requirements is that the size of each resample or each subsample must be equal to the size of the original sample. So अगर original sample में 5 values हैं, so you must have 5 values in each subsample that you construct using the original sample. You cannot have less than 5 values, and you can certainly not have more than 5 values. Essentially, even if you were to somehow increase the size, you are still constantly sampling from the same 5 original values. So, the solution to this is that you have to increase the size of your original sample. Maybe your original sample was not diverse enough to begin with. Are there any questions at this point? All right, so from my side, that will be it for today, actually.